Good morning, students. Today's topic is register, transfer, and micro operations. Let us first understand what do you mean by register, what do you mean by transfer, and what is micro operations. You might have used and seen register. We see long notebook is also called as a register. You writing in your register. You write your notes in your register, right? Or we can also have a student's attendance register, teachers attendance register, meeting register. It is like a book. So what happened in this book, if you can store 20 lines of information, you can write down like this, 1 2 3 and so on up to 20th line. You can use it for later referencing if what you have written. Consider that this register gets full. Okay, you have written everything in this register, and there is a concept which you have written on one page, on the last page, which is to be continued in your new register. Okay, this is our old register, this is our old register, and this is our new register. So what do? You just copy that last page, because that is continuation. It is not ending in our old register, it is being um, you know um, extended in the new register. So you just write down that last page of information from the old register into the new register. That is what is this, you can call it as a register transfer. You are transferring some information from one register to another register. Register is a book, we can say, generally. So far I'm talking about general analogy. Okay, consider this as an analogy, an example. So register is a book where you can write some information. Okay, and register transfer is you are copying the information from one register to another register. And what is micro operation? What operations you can perform on a register? If you are writing with pencil, you can erase, you can write again, you can tear a page paper also from the register. You can create your table of contents in the register. You can perform different operations on the register. All right, this is with respect to analogy. Moving ahead to the computer register, what is it and how it is relevant? Let us try to understand. In a computer system, there are memories. What is a memory? What is the need of memory? Memory is used to store the information, and also you retrieve the information from the stored um, content. You can also retrieve the information, and you can store the information. That is the use of memory. Memory, there are different types in a computer system. Basically, you have memory two types: primary memory and secondary memory. In primary memory, there is a RAM and ROM. A secondary memory, there is a hard disk, CD. These are general categories. More variants are available. RAM variants are there, ROM variants are there, hard disk variants are there. There are number of CD um, variants that you can get. These are basic types. So memory, you have primary, secondary. Primary, you have RAM, ROM. Secondary, you have hard disk, CD. And also besides these, there is a special memory which is known as a register memory and a cache memory. These two are um, related to processor. There is a unit in a computer system which is known as processor. This processor task is to perform various computations and numeric operations, textual operations, arithmetic and logical operations, relational operations. Various operations and computations are performed by this processor. This processor is connected to RAM, which is a main memory, random access memory. This processor has got three units within it. There are three parts within a processor. What are the three parts?
Ma'am,
Yeah, yeah,
hello,
yeah, yeah, yeah,
ma'am.
yeah. Pawan, tell me.
Ma'am, a few students wants to join the class, but they were unable to join the
Okay.
class. Will you please
Yeah,
add
yeah.
them?
I have admitted.
Yeah. Thank you, ma'am.
Okay. All right. This processor has got three parts. It has a memory, it has control unit, and it has arithmetic and logic unit. Okay, this is coming to MCA. Memory, control unit, memory, control unit, and ALU. What is this memory? This memory within a processor, which is a part of a processor, is known as a register. Register is a memory built within a processor. And then what is cache? There are various pronunciation for this cache. Some pronounce it as cache, um, some cache. So you can pronounce it in your way. So a cache memory is a special and high speed memory between processor and RAM. Here you will find cache this side. This is cache memory. Yeah, this is fourth chapter. Students, any doubts in this memory concept? You have memory, different types, primary, secondary, and these two are also types of memories which are associated with processor essentially. Processor is a component within a computer system which performs all computations, and it has three parts: memory, control unit, and ALU. And this memory is nothing but the register. Also, processor is connected to RAM to store the information or data and to retrieve the information data. This is communication between processor and RAM. In between this processor and RAM, there is a high speed memory which is known as a cache memory. Okay, or cache memory or cache memory. Here, this one is this. In this chapter, we are going to learn about which memory? Register. What is a register? Register is a memory built within a processor. Okay, and there are different registers within a processor. It's not just one. Like when you come to your college, in your bag you place 5 or 4 registers. It's not just one register typically. Okay, there are few students who carry one register and write everything in that, but then generally um, every register belongs to every subject, and therefore you have to carry 4 or 5 registers. Likewise, there are different registers. You can have 10 registers, you can have 20 registers. It depends on which processor it is. There are different types of processors, like you have Intel processors, um, Apple processors, Mac processors. So different processors would have different number of registers. This is all about processor's memory registers. And register transfer means when you are transferring the data from one register to another register, it is known as a register transfer. And micro operations are those operations that you can perform on the data stored on the register. Okay, uh, this is what we are going to study in detail in this chapter, which is unit 2 of your syllabus, register transfer and micro operations. A micro operation is an elementary operation performed on the information stored in one or more registers. Okay, remember this definition of micro operation. Digital modules are best defined by registers they contain and the operations that are performed on the data stored in them. Digital module, nothing but part of a digital system. What is a digital system? It is an interconnection of digital hardware modules that accomplish a specific information processing task. This is the definition of a digital system. This one is digital module, which is nothing but a register in this case, and this is micro operations. The internal hardware organization of digital computer is defined by set of registers it contains and their functions. Sequence of micro operations performed on the binary information stored in the registers, and the control that initiate the sequence of micro operations. Let us discuss this with the analogy. You have got set of registers. You have a register for CA subject. What is the function of that register? You are storing and writing the notes, class notes, the assignments, and the problems. Some of the problems you are solving, and you're drawing some logic diagrams or circuit diagrams. That way, in a computer system, a process within a processor, there are set of registers. You can have registers like R0, R1, R2, and there are some specific registers like accumulator, program counter, address register, uh, data register, temporary register, input register, output register. These are different registers, and every register has got its function. For instance, if I take example of program counter is a register that stores the address of the next instruction to be executed. That is the function of that register. Sequence of micro operations performed. What operations you can perform um, on the binary information stored in the register? If I take a generic example, analogy, in your CA nodes, what is the use of your CA nodes? You can read them, you can recollect, recall, make important points, and then what do you do in computer system? In this side is computer system. This side is sequence of micro operations, means you can perform arithmetic operations, you can perform logical operations, you can perform shift operations. Various operations can be performed. And what is the third point? Third point is this control that initiate the sequence. When you take out this CA notebook from your bag, whenever there is a class as per the timetable, apparently, right? You have got the timetable, and then when you look at the timetable, you find that at 10 o'clock there is a CA class. So what do you do at 10 o'clock? You take out the CA notebook, that is a CA register. That is the control, that timetable will control. Here, control unit of a processor will control. Here, control unit will control. When uh, micro operations have to be performed. Okay. And then there is a register transfer language. What is a register transfer language? The symbolic notation used to describe the micro operation transfer among registers is called the register transfer language. When now you are learning Java, Java has got its own language. It has got its own keywords, its own syntax. C, it has got its own uh, language. Likewise, when you are doing register transfer, it has got its own language, its own symbols. So that is register transfer language. All right. So now what is register transfer? Let us look at this block diagram. This is register R. And here this one is showing the individual bits. How many bits this register R1 can store? Can anyone tell me? What is the size of this R1 register?
8 bits.
Very good. Why it has got the range from 0 to 7? Here you look at this. This is 0th bit is the first one and 7th is the last. although its size is 8 bits. 8 bits means what? 1 byte. The size of this register is 1 byte, but then we have learnt that always the numbers would begin from 0 and end with n minus 1. So here n is 8, so it would be from 0 to 7. Okay, so this is 0th bit, first bit, likewise the last one is 7th bit. R2, what is the size of R2? Yes, you can put in the chat window as well. Can anyone tell me what is the size of R2?
16 bits.
16 bits. 16 bits. Very good. Students, those who are going with this number, please note that this is the number which is beginning at 0. Because we are beginning at 0, if you include 0 also, it would become 16. So the size of R2 is 16 bits, which is equal to 2 bytes. And the range would be 0 to 15. This R2 now has been split up into 2 parts. This is low byte, this one is high byte. Low byte, the range would be from 0 to 7 and high byte would be 8 to 15. Totally would be again 16. This is how you number the bits in a register. You can represent the register just as a box or a rectangle and say that this R1 size is 8 bits, or you can individually denote the position values, which is 0 to 7, and you can say this is R1 with 8 bits. When you are talking about a register with 2 bytes or 16 bits, you can divide it into 2 bytes, which is low byte and high byte. This PC is program counter. We will learn as we go ahead. So here, this one, okay, this one. What is this? Information transfer from one register to another is designated in symbolic form by means of a replacement operator. Can anyone tell me which is a replacement operator in this expression? Students, can you tell me which is a replacement operator?
Arrow
R1.
mark
Replaced by
going
R1.
towards the left.
Yeah, very good. This one is the replacement operator. And what are R1 and R2? What are R1 and R2?
Registers.
Very good. Those are the registers. R1 and R2 are two registers. Now, what are you doing in this? Can you tell me?
Data transformation.
From where to where?
From R1 register to R2.
Very good. So you got this point, right? This
Yes, ma'am.
statement denotes transfer of content of register R1 into register R2. This is like, you can say A is equals to B. Suppose in Java you can create int A comma B, okay, and you can say uh, B is equals to 10. If you say A is equals to B, then what happened? A would also get the value 10, because whatever is there in B, that you are copying into A. Likewise here, this is at a very low level, at the hardware level. at the register level. Here you don't talk about registers or RAM or anything. Here you directly talk about variables. There are two variables, A and B, and then you are initializing A with a value 10, and then B, you are initializing with a value 10 and you are saying A equal to B. Then it will be A is equal to 10, like that. Okay, so this register transfer, here you need to understand that because um, we say that control there is a control unit that directs the transfer, and that statement can be written in this manner. If p equal to 1 means, what is p? P is a control signal generated in the control section. If it is equal to 1, 1 means true, 0 means false. So if it is equal to 1, it means that it is okay. If this condition is true, if this condition is true, only then this transfer takes place. Otherwise, this transfer does not take place. If it is false, that is denoted in this manner. This is control variable, control signal, and this is known as a control function. When this condition, when this condition is true, then only this transfer happens. Okay, the third statement which we studied, that there is a control that initiates the transfer process. Okay, this one. Okay, students, please try to understand. This is known as a timing diagram. This try to understand. This is very important. Timing diagram. This is clock. Our clock in a computer system primarily comprises of 0 and 1. This is 0. This is 1. Here there are two zeros. 1, 0, 0, 0, 1. So this implies false clock means there is nothing here. 1 means there is positive value, which is or true. When a transfer occurs, that can be denoted in this timing diagram, like here there is a control circuit. There is a circuitry. Okay, there is a circuitry that generates P. What is P? P is a control signal. If this control circuit generates 1, means true signals, if it is true, then this load would be equal to true, would be equal to 1. In that case, what happens? Here there is a clock. This clock is tied up to this register. When this is true and this is true, then what are you doing? You are transferring the contents from R1 into R2. What is this n bits? You are transferring n bits from R1 into R2. When are you transferring? When there is a condition which is satisfying, which is equal to 1, and also there is a one at the clock side. One at the clock side means what? Clock should be clock should show like this is one in clock. Okay, this is 0 in clock. So there should be 1 in the clock and there should be 1 in the P. Only then you're transferring. This is depicted here. Clock is 0, clock is 1, and load is 0. This is load 0, 0, 0, 0. Here at this time, load has become 1. When load is 1, clock is means when load is 1, At that time, clock should take a positive edge, means move from 0 to 1. When clock moves from 0 to 1, when there is load equal to 1, then transfer happens. So here, when load is change, when load has become 1 here, clock is 1. That time it will not happen. When it should happen, load is 1. See, load is 1. This is load L. This here it is 1. And at the same time, clock should be, when load is 1, clock should here at this point. This point, what is happening? There is a transition happening. What is a transition from 0 to 1? At that time, transfer happens. This is known as positive transition when you are going from 0 to 1. And negative transition is when you are going down from 1 to 0. This is 1 and this is 0. When you are going down from 1 to 0, this is negative transition. This is positive transition. Any doubts in this diagram, timing diagram? Here, when look at here, clock is moving, taking a positive transition from 0 to 1, and here this is 1. So at this juncture, transfer occurs. Any doubts in this? Okay, if you look at this table 4.1, there are basic symbols for register transfer. What are the basic symbols? Letters and numerals, means like R1. R is a letter, 1 is a numeral. R2 or MAR or ACC, PC or IP or okay, yes. Who has raised the hand? Any doubt? Anyone is having any doubt? You can ask me. All right, student. These denote a register. R1, R2, MAR, memory address register, program counter, accumulator, input register, output register. These are letters, combination of letters and numerals denoting the register. Parenthesis means denote a part of register. If we say R2 of 0 to 7, we are talking about low order byte of R2. If I say R2 of 8 to 15, it is high order byte. Or we can also say R2 of L, R2 of H. That is parenthesis. It denotes the part of a register. This one arrow is replacement operator that denotes the transfer of information. Comma separates two micro operations. This is the transfer is also a micro operation. Transferring from R1 into R2. This one is transferring from R2 into R1. Both are micro operations. Both are separated by comma. In Java, what you can do? You can say int a comma b. This is variable declaration by separated by comma, or you can say int a semicolon int b semicolon. This is using two separate statements, this one joining by a comma. That is all about register transfer. Going further, bus and memory transfer. Can anyone tell me what is the use of RTC bus? What is the use of RTC bus? Okay, let me see. Transport with low cost. Very good. Why it is low cost? Tell me the reason behind. Yeah, we can save money. That is also right answer. Why we are saving money? Why it is of low cost? What is the reason? Very good. Because we are sharing. We are sharing means there is one common vehicle that is carrying multiple peoples from multiple locations to multiple locations. If you go for, if you take a Uber taxi, not on sharing mode, your individual, if you book a cab, then what happens? You have to pay more. Why you have to pay more? Because you are the only one who has to bear the cost. But then if you go with go on sharing basis, if you book a cab on sharing basis, then yeah, very good. You are a specific person and a specific location. You have to bear the entire cost of that. But if you share it, then what happens? There might be several picks, and there might be cost would be reduced because you are sharing. That is the concept also being employed in computer hardware by having a bus. A bus is a common system which is connected to multiple registers which carry data from multiple registers to multiple registers, like this, in this format. This is a common pathway which is connected with all the registers, and this register can send the data will travel on this bus, and perhaps it will be sent to this one. So a bus structure consists of a set of common lines, one for each bit of a register, through which binary information is transferred one at a time. And bus is an efficient mechanism. If you don't use bus, then you have to have a separate set of lines between every pair of register. Between register, consider this is R1, R2, R3. R1 has to be connected separately with R1, R2 and R3. R2 has to be connected separately with R3 and R1. Likewise, every two registers must have to have a separate line, which is not efficient because it takes more space on the circuit board. This is our circuit board. Okay, it takes more space. It would become bigger in size. It is by no means an efficient mechanism to have a separate lines. And the alternative mechanism is to have a common line, which is a bus. The next question that arises is, how can we construct a common bus system? One way of constructing a common bus system is using multiplexers. What is a multiplexer? Okay, we'll look about it. Another way of constructing a bus is using a three-state bus buffer. There are two ways. Here, bus system can be constructed either by using multiplexer or by using three-state bus buffer. What is multiplexer? That you need to understand now. Multiplexer, also denoted by MUX, MUX. MUX means multiplexer. What multiplexer does is it takes input from multiple sources and forwards any one data from any one source onto the output channel. MUX is like this. This is our multiplexer. It has got n inputs. Here this MUX is 4 by 1. 4 by 1 MUX means what? There are 4 inputs and 1 output. You can have a multiplexer of size 8 by 1. Then you will have 8 inputs and 1 output. Output is always 1. Apparently, you can have multiple input combinations, multiple input values. You can have 2, 4, 8, 16, but then output remains to be 1. Alright, so you can have a 16 by 1 MUX. In our example, we are using 4 by 1 MUX. When you use 4 by 1 MUX, there are 4 inputs. You get one input from uh, one register. Look at this configuration, try to understand it. There is register A, register B, register C and D. How many registers are there? 4 registers are there. What is the size of each register? You see here 0, 1, 2, 3. Likewise, all 4 registers have 4 bits. So size of each register is 4 bits. And each bit has been named because this is register A. 0th bit of register A is named as A0. This is A1, A2 and this would be A3. Look at register B, B0, B1, B2 and this would be B3. Likewise, C0, C1, C2, C3, D0, D1, D2, D3. These are the symbols for each bit in the register. I hope that this part is clear to you. There are 4 registers. Each register has 4 bits and they have given the names. Okay, based on the register name and bit position value. Look at this part, the upper part, which has 4 multiplexers. Why there are 4 multiplexers? We know that each multiplexer would give 1 as output. And we want 4 lines, 4 line common bus system. Why we need 4 line common bus system? Because we have to carry 4 bits. Here each register has 4 bits. So you have to carry 4 bits of information. That's why we need 4 line common bus. This is line 1, 2, 3, 4, or you can say 0th line, first line, second line, and third line. So 4 lines. From where you are getting these lines? 0th line you get from mux 0. This is 0th line. This is first line you are getting from mux 1. This is second line you are getting from mux 2. This is third line you are getting from mux 3. 3, 2, 1, 0. All right. Let us look at this configuration now. Okay. Let me check what are S naught and S1. Yes, I will explain you X naught and X1. Here mux naught is getting 0th bit of every register. Try to understand this. A naught, B naught, C naught, D naught. What is mux 1 getting input from? From all the 4 registers, which bit? First bit. What is mux 2 getting? It is getting second bit from all 4 registers. And third multiplexer is receiving third bit, okay, from all the 4 registers. The next question that arises is, from here when you are when multiplexer is receiving 3, 2, 1, 0, these bits which are coming from 0th bit of every register, which bit should be sent out? A bit, B bit, C bit, or D bit? Here what should be sent out? Let me give you an analogy. If 4 students are asking one question to me, 4 different questions. 4 students are asking 4 questions. Which question should I take first? Which question should I take next? How should I decide? I should have some selection mechanism. That selection mechanism is determined by the bits of these S0, S1. These are select lines. These are known as select lines. Okay. You see here S0, S1. When you both, when they both are 0, 0, S0 is 0, S1 is 0, which register would be selected? Register A. When S0 is 1, S1 is 0, register B would be selected. When S0 is 0, S1 is 1, register C would be selected. When both are 1, 1, register D would be selected. When they are receiving input from multiple registers, which register input should be chosen or selected and should be sent out on the output line is determined from these 2 lines. Look at here, these 2 lines are being attached to every multiplex. Here these 2 are attached, and here also you have, here also you have. These 2 main lines are running, and from these lines, like how you have cable network, in the cable network one big line is placed and it is tapped, and multiple connections would be given from this main line that would be running across the road. Likewise, 2 big lines are running here, and you are tapping the connections to every multiplexer, and the values of S0 and S1 would determine which register should be selected. When both are 0, 0, so here you are getting 0, 0, here you are getting 0, 0, 0, 0, and 0, 0. When all four multiplexers are receiving 0 0 as the selection line input, then what they will select? This zeroth value. What is this zeroth value? This 0 is A0, this 0 is A1, this 0 is A2, this 0 is A3. And here it is carrying A0, A1, A2 and A3. So this line, this bus line will carry information from register A. Students, is this clear to you? Do you find it difficult? Do you want me to explain it again? Did you understand this bus system constructed using multiplexer? Okay, I am going to repeat once again this part. Here the idea is to create a bus system. A bus system is a common structure that carries information in the form of bits from registers. Here you are constructing a bus through uh, multiplexers. What is a multiplexer? Multiplexer is a um, circuit that takes multiple inputs and gives out only one output. Okay, multiplexer. This multiplexer is a circuit which takes multiple inputs and gives one output. There are four registers. Each register has got 4 bits. There are 4 multiplexers, and the size of each multiplexer is 4 by 1 because it is receiving input from 4 different registers. And these are the 2 input lines which are known as select input lines or selection lines that will determine which input to be given out as output. On this line, which input should be sent out. All right, these are input lines. This is output line. This multiplexer is receiving 4 inputs. Which input it should forward on the output line? That is determined by this selection lines. Okay, so these multiplexers have got 4 inputs. They receive multiplexer 0 would receive 4 different inputs from the 4 different registers with from their zeroth bit of every register is multiplexer 0. Multiplexer 1 is what? First bit of every register. Multiplexer 2 is second bit of every register. Multiplexer 3 is third bit of every register. And then now which register is sent out on the common bus is decided by this S0 and S1. When both are 0 0, S0 is 0, S1 is 0. Zeroth input of every multiplexer is chosen to be sent out on this output line. So when you are passing 0 0 through S0 and S1 to all the multiplexers, you are actually choosing register A because the zeroth bit of multiplexer 0 is A0, zeroth of multiplexer 1 is A1, zeroth bit of multiplexer 2 is A2, zeroth bit of multiplexer 3 is A3. So here you are this bus line will carry the information from register A. Students, today you go through this If you don't understand still, you can ask me in tomorrow's class. Tomorrow again I will take class at 9 o'clock, 9 to 10. Tomorrow again I will take class. Okay, students? Bye for today.
Hello, madam.
అన్నా రా